Hey, hey, we're going to learn 8-4, angles of elevation and depression. Our objective is to use angles of elevation and depression to solve problems. Here's a little high school musical that some of you might enjoy looking at, stuff with angles of elevation and depression. So what are these angles we're talking about? Well, an angle of elevation, if something's getting elevated, it's going to get higher. So we're looking at the person right here, and their eyesight, you have horizontal here, and then there's a certain angle formed looking up to the object, and that is your angle of elevation. And then any object, maybe in the sky or wherever it's at, looking down, so you have your horizontal line and then an angle looking down. That's the angle of depression. Depression usually means down, maybe a person is down, and then elevation means higher. All right. So here we're going to identify angles of elevation and depression. So if we look at angle 1, it's the bird looking down to the person. That'd be a little bit scary, but that would be an angle of depression from the bird to the person. Number 2, that would be an angle of elevation from the person looking up to the bird. They're just making eye contact like birds and people do all the time. Alright, then the person, horizontal out, and then they're looking down at the bottom of the mountain. That's an angle of depression. And then the mountain with its eyes at the bottom, the hills have eyes, the mountains have eyes, whatever. They're looking up at the person, and that's an angle of elevation because it's looking up. Good. All right, so now we're actually going to apply this to a problem. Suppose you stand 53 feet from a wind farm turbine. Oh, sorry. So suppose you stand 53 feet from a wind farm turbine, right here. And from your eye level up, it's a 56.5 degree elevation. And then your eye level, basically your eye level down to the ground, is 5.5 feet. So we're going to set up a trig ratio. From this angle, we're using opposite leg and the adjacent leg. So therefore we have to use what? Let's see, TOA, tangent. Okay, so tangent equals opposite over adjacent leg. And you can see that's what they do here. So x over 53, then multiply the 53 over to this side, and you'll get about 80 feet, you could see. And then we want to know how tall is the farm turbine, the wind turbine here. So the x value is 80 feet, but what about this distance from the eyesight down? That was 5.5, so you add that to 80 and get 85.5 feet. Very good. I'll leave this problem here for you in case you're interested in pausing the video and kind of trying that one. Alright, on to the next page. Alright, problem 3, using the angle of depression. So here we have an airplane, very realistic. It has to kind of measure out its angle of depression to the airport. So it's going to descend at a 3-degree angle, starting at 2714 feet above sea level. Now here's the thing though, the airport is 1,007 feet above sea level. So what's the distance here? Well, 2714 minus 1,007, you'll get 1,707 feet. And you can see that's what they do right in here. So now we kind of have a new problem. And the angle of depression was 3 degrees. Since there's alternate interior angles, you see the Z shape. This is also 3 degrees. So now we could use, let's see, opposite leg and hypotenuse is the x. That's what we want to know. How long is this distance from the airplane to the runway? So again, opposite over hypotenuse. That is sine. So sine of 3 equals 1707 over x. We could kind of multiply x to the other side, divide sine of 3 here, so it kind of switches, and we get 1707 divided by sine of 3, which is 32,616 feet. Sorry, let's see. Yeah, feet. And then we want to divide that number. It wants our final answer in miles. So just to kind of make it easy, we will divide by 5,280. That's how many feet are in a mile. And get 6.177 miles, or to make it easy, 6.2 miles. So that's all for today. Here's a little problem you could practice. By the way, those sneezes earlier were just a joke. I was not actually sneezing. All right, have a great day. Bye.